Hey guys, it's Chris, and we're working on yet another Amiga 3000. This one is Mr. Bill's, so I'm going to pull it out of the box. Inside we have a Revision 7 standard riser board. Yep, plastic thing. Put that to the side. Oh boy. So, the normal culprit, Denise, Paula, and her buddies, Amber, battery damage, and some wires on top. Yay! This is green. This is green. Holy moly. So I'm going to be using my spare Amiga 3000 power supply without the proper button where I have to. So I just leave it on, have it on a switch, that way I can plug it in and it doesn't come on until I physically flip the button on the Memorex Power Center. To test an Amiga 3000, we're going to be using the Commodore HD1552DL, or you can purchase repops buffered from Amiga Kit. This one's lighter and it's thinner and I don't have to lift the board up, so there's a big comparison. This one's nice and thin and can work with the board being laid down. Flip my work mat over. Yes, this is just a floor mat from the dollar store. This does not have the capacitor fix for the later revisions. The radial capacitors actually look good. Oh my goodness, that's good. When you got a tight one and you gotta really shove it in there, that's great. Now, I haven't touched a thing. Denise is green, and is green coming out of the bottom. The pull-ups on the side next to Paula are, the whole thing is just green and acidy white. The amber buffer impossible chips are probably gone. The 3 Oki datas, they're gone. The phase lock loop, that's gone. Yup, that's gone too. That's bad. But this amber doesn't mean it won't work. It'll work fine without it, as long as you have a good Denise and a good Paula. And my eyeballs hurt already. Here we go. No smoke. And a blinking high. See this blink, blink, blink? Oh, it did 5 reboots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Green. 1 fast blinking. Yellow light on the yellow on the screen. That sucks. Nothing. Nothing at all. You know what the story is? Denise, Paula, her buddies, battery barf, and throw up. Board I've had for almost a month already, and I really haven't had a chance to start on it because I had 2 other Amiga 3000 repairs and a 2000 repair in front of it. And I had to order additional chips, additional sockets, additional parts, so I could fix, hopefully fix this. Alright, so diagram doesn't like it, so that's not good. It's a light show. I've only seen teal one time in my life. Hello again, it's 12:32, and as you can see here, we got Denise and Paula out, and oh, so that all this stuff right here is green, and green. I don't know if you can really tell how green it is because there's such luminous light above me. Moving over to Paula, she's green too, and you can see the acid etched underneath her dress. Yeah, this ain't France 1970. Gotta clean her up, nice and smooth now. These weird hairs and resistor bodges across the amber, and I don't know what this is. I'm gonna have to check that out. So, I mean, good job on the wiring, if that's where it's supposed to go. This socket's toast. It's leaking out of the top. And Paula has bark everywhere. This is mainly I/O control. Floppy disk boot works with her. And this. Oh my, how'd you get acid all the way down here? Oh my. Oh my, we're down to here, into the glue logic. So, weird thing is, RTC, it's been cleaned is what it is. Yep, lots of scuzz everywhere. This is it's another 16 megahertz. I think the 16 megahertz machines are death. I don't know. They're the most problematic ones that I have in my repairs. They're always an issue. We've had some work done. Here's more solder blobs and heat on these RAM chips. Couple of cotton round cleaners on Paula. Denise and Paula are untouched as far as my brain can see. 6030's got weird crap on it. Where do you guys find these things? Are you just pulling them out of the swamp? I get the worst of the worst ones. I tell you, it's such. Oh, but I want to thank each and every patron supporter. Without you, none of this will be possible. This board for Mr. Bill, all the fellow patrons and supporters help pay for the repairs that I do for people. Long ago, when I was a weenie deenie, what? Long time ago, when I didn't have you guys, I had to fund these myself. So I had to charge people, sometimes upwards of $300 for a repair. But I don't go over that. I never did. And I didn't do a lot of them because I didn't have the parts or the means to do that, and the time it would take me, I would just lose money. If I would dump 40 to 50 hours into some of these, like Rusty, it was 51 hours just tracing stuff. It takes a long time, guys. So if you're a paid repair shop and you're going for anything other than a recap, that's why it's so expensive. The diagnostics and just parts for these and the time it takes to troubleshoot these, if you're charging someone $70 an hour, it's not feasible. You could just go buy another one on eBay that worked for the cost it would, you know what I mean? The time and labor. But that's why I do these, quote, free pairs with your help, because it saves the boards that people thought, well, I can't ever afford to get this fixed. And that's what I'm doing. So I'm not out. I am out to make $1 million. I'm going the wrong way. You're supposed to make positive money, not charge $9,000 on your credit card for your YouTube channel a year. But it's a bucket list thing, and I'm trying to get it done. These chips are going to have to come out and get socketed. I actually ordered the correct sockets, so we have those in stock. Sockets for Denise and Paula. I have 4 left. These are the same sockets that Commodore used, minus they have a double bracing instead of a single bracing. So these wicks I use are solder wick. This is crap because it's like dental floss. So I'm going to be using the Avon desoldering wick. It's what I always use. It has a holder in it. It just works better. Plus it's $10, comes with 4 rolls. 5 rolls because you get one in it, 4 spares. When this stuff is like $4 or $5 a roll, when it's one of those, if I can find this, I always buy this one. Great. $9 for one Heiko tip. Put this one on. It's the same exact tip. The same exact tip. $2.99. Same exact tip, same thickness. $9. Why? Because it's pretty. This is lead tin silver, which is way better. SMD, Chip Quick. You know, the Flux company. Don't want to risk pulling all the solder sucking out on these pins, so it's easier to cut the socket. Just cut it and actually pull the plastic off of the pins, and that just totally rotted out. That was totally rotted. It just broke. So that's horrid. 102. That solder sucker, this solder sucker from Kotto, solder sucker, it's the official name. Works great. My problem is this thing gets clogged and it shoots out lead diarrhea. These came out clean, but you can see the acid. You can really see it here. And this looks pretty bad. But let's see what a little IPA on a cotton swab can do for us. And we're going to have to do this stupid Paula and the busted lines, but at least stopping that acid. Now I'm just going to do IPA now. I'll do apple cider vinegar in a bit just to neutralize anything. Yes, I know I still got to get that ground plane out. So here's Denise right now after a butt wipe and a socket removal. I still have to get this ground pin out right here. Okay, Paula's out. She looked horrible too. So here's Paula. Now, seen my other Amiga 3000 videos, and That's what happens. The battery is literally right here and it barfs. And when your socket can look good on the top, it's what's underneath that counts, because the primary areas on an Amiga 3000 that break are Denise and Paula and the amber logic. This is an NE564 phase lock loop. It takes the 15 kilohertz signal and makes sure it's in phase with a 28 megahertz signal, kilohertz signal. It's got some science and some math, and these other RAM chips are the R, G, and B. These are the buffers for amber, the Vidiot 1, Vidiot 2, 31, 15. It's nice. There's an ALS 7404, there's a 157N, there's a bunch of different quad hex inverters and buffers. They're glue logic that help these chips talk to the other chips.
Understand the words that are coming out of my mouth?
The battery barfs all over everything. It doesn't really matter if amber doesn't work, you can still get RGB or RGB out of the 15 kilohertz port if your logic's okay. You can see my other Amiga 3000 video where I replaced everything in here and that amber would not come back. So it was either a bad amber or this RAM that we sourced from where the hell ever. The RTC is another area that can be affected. That is south of the battery positives. This is the negative and this is the positives. The RTC trimmer cap along with the 31 kilohertz trimmer cap. It's a 2 to 7 picofarad variable capacitor. Still readily available. Caps are standard. Agnes here, the A3072B. It's a B or an AB. It's unique to the 3000. You can also mod and do an 8375 with an adapter board. It's currently 1:42 p.m. We have two new sockets soldered in, bloop and bloop. You can see the darkness because of the flux, and I have to clean that up. So solder came well. I don't know if there's any broken traces yet. First step is always sockets, and then we'll clean up the chips. So let's do this again. Now the cool thing about the Amiga 3000 and the Super Kickstart, it's a pain in the butt. You need one of these. This is a Super Kickstart disc. But there is a trick to the Super Kickstart. If you do not have a DF0, this will not work. What if you have a DF2, like I have plugged in here? You can see this Epson. I have a bootable copy of sysinfo. What you can do is this. Check this out. If you take your mouse and move it all the way to the top left and click, the screen freaks out, and you get a beta 1.4 ROM. Maybe. Yep. Look familiar? The Kickstart screen does, but beta do not redistribute Commodore. Now, I can boot like a 2.0 ROM with a boot selection. Just put a disk in. Sysinfo, bootable. This will load. It'll take a longer bit. She's loading. Look at that. So we have sysinfo on a no kickstart. We are in RGB mode. This is sysinfo 4.4, 68030, 881. All the caches are off except iCache because, you know, I don't have a set patch running. So we're gonna hit speed. It's 16 megahertz. I know in advance. So it'll be half of the 3000. A little bit faster than the 020 Amiga 2500. Great. But it gives me the ability to see my 8 megs of RAM, 2 megs of chip. Cool. Now I can actually boot an Amiga test kit disk, which I have written to physical media with a super fancy label. There we go. Cool, huh? I was waiting for the music mod to start playing. I gotta write the new one. Test this RAM. 8 megs of fast and 2 megs of chip. Okay, so we passed the test there. We're gonna stop it. Alright, we did audio, mouse, we know that's working. I'm not worried about gamepad. Video, RGB, we can't do the other one. CIA, battery backed up clock. Wow, it detects the time. Needs a battery. CIAs, this is NTSC. CIAs are good. Interesting. That's rare. Serial parallel requires a dongle I do not have. You can buy one at Retro Rewind.ca. It's nice to have a secret boot menu on a 3000 so you don't have to do some crazy kickstart ROMs that I'm out of. I burned my last pair for Rusty and I need to order more and they're like freaking $60. So, got the latest ATK at least, and a sysinfo, and a super kickstart disc if I had a DF0, but I don't. Anywho, oh god, it's 5:08. I've been farting around this 3000 for hours. At least we're working. So I need to go through it more, and we're going to see what we can come up with for amber issues. I hate amber issues. They're always messed up, and this battery bar sucks. I'm going to remove all three of these chips. The NE564, this 74 ALS, and this 5 whatever the other one is. I forget names. You're getting a brand new chip in a socket, buddy. I'm going to do what I always do with chips of this nature. Right here, this, yep, we're going to cut it. Flip your tool around the other side. Get close as you can to the top of the chip. And just snip it out. Now some of these legs are going to come free because they were already out. So here's our chip. Right, you saw how I removed it. Now the reason I remove them like that, I've said before, that way you can take some solder tweezers, they self-close, heat your soldering iron up, and you can just simply touch the pin and it comes right out cleanly, and you don't damage the holes. Oh yeah, that looks tasty. Okay, 2:37 p.m. Took a little break to take a phone call. Talking to Mr. Mike way out in West Coast. Anyway, it's nice to talk to people. I don't have any real friends in real life. Don't mean a pity party, but I enjoy talking to you guys. If you ever want to talk, go ahead, feel free. So we have a new socket here in this 7407. Address any issues that pop up with the continuity tracing with these lines. They'll probably be moved underneath just for appearance. Lunchtime. 74 HCO4. There we go. Pin straightener. RetroRewind.ca. Pick yourself up one today. Use my code NOCODE. Save 10% on your shizzle. Now we're going to test out the old flicker frickin' fixer. Enable. I think amber's toast. Like toast. RGB. RGB all day long. That didn't work for nothing. That was a pain in the butt. So, on to the next thing. I'm going to try the phase lock loop. Phase lock loop is a NE564N phase lock loop. Does some science. Works with the 4210s, 4210C buffer chips here. These talk to these, and that makes amber work. There's 2 vidiots and 2 hex inverters up here that all create the science that makes amber work. If amber works. The problem is, amber doesn't even work in regular mode. So, I'm going to try a phase lock loop. I'm going to put a socket in it, which reminds me, I got to run upstairs. I got my sockets in finally after a month, so I can continue this board. Where this 1K resistor right here is supposed to stick at, really messed up over here. Holy crap, this thing is muffed up. This is your phase lock loop circuit. It is just destroyed. Oh my goodness. Yep, that's green as the ocean. And here is our new SIL turn pin with a brand new NE564 amber in the up position, RGB, new phase lock loop. Pretty sure it's still toast, not even a signal. Power save mode, flicker fixed, monitor in sleep mode, nothing. So, what's next? I'm going to use Tristan's blog here. I've used Tristan, his website before. Tristan, thank you for having this. I'm going to bust out the oscilloscope, and I'm going to look for a VCC bus on pin 6 of the phase lock loop. So what I do always before I get going on my oscilloscope is I check the calibration of my probes. There is a 1 kilohertz generator right here, and I'll just give you a quick show you what I do. So I clip on my ground wire to the ground pin, poop, and then when I clip this on, I'm looking for a perfect square wave. And then I'll hit auto, and this thing will do that. Now, you see how this looks not really perfectly square? So what I do is I take a little screwdriver here, and there is a trimmer cap in here, just like on the boards, and you kind of twist it until you get her down. Look at that. Way nicer. Way nicer. 1 kilohertz, which is what I'm in, which is great. Even though there's a little bit of noise on here, no big deal. It's square. And I'm in the 1 kilohertz, and we're good. What does that mean? That means I can use this probe without it freaking out. That's just me taking the crap off. 50 nanosecond. I am at 10.9 megahertz. Yeah, I'm turning this freely and bigly. Bigly, this does nothing. This trimmer cap isn't even hooked up or doesn't work because it's not doing anything. 10 megahertz, 41, 10.5, 10.5. Good God, this thing's jumping around like a daggone, like a music vox. So that's not right. Okay. I love you, Amiga 3000. I love you. You know that. Pain in the rear end to work on and repair. You really are. I'm sorry. You just are. So we're heating the soldering iron back up, and I'm going to deep dive back in. Again, I was using Sprint Layout Viewer. 3000 files. Going over the wonderful Amber circuit, which is just a blessing to work on. It really is. No. And we're going to continue in a bit. I am going to probe this. You've seen it 1,000 times. If I find anything significant, I'm going to blip back. Probably going to have to replace this trimmer cap if it's toast, because it's like, looks like I'm poking an old booger nose with a screwdriver. It's just, this thing must have been stored like this, because it's, all this is just white, ashy, burnt out, just beautiful. Bored the living daylights out of you. So, after the NE564 phase lock loop and all those crazy wires that were on top, I fixed all those boo-boos, and that resulted in spaghetti with meat sauce. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 solder points to fix busted traces underneath. Thinking about hitting the wobble pops. But I don't like to drink and drive, so not while I'm repairing someone else's Amiga. Continuity means beep beep between all the points that it goes to, all pins, both sides. That was fun. With that, picture looks very nice, very crisp. We're going to take the VGA port here, and we're going to go into disabled Amber. I'm convinced this Amber is toast. Enabling Amber. Scan doubled for a signal that it doesn't get. That's everything. Let me do the trimmer cap, and then we'll try again. New trimmer cap. There we go. Also, while we're in here, when I solder something, I like to just make sure that everything's cool. Good? Good.
Everything's cool. Everything's cool.
Divoom came on. That means the screen is RGB in. And then we'll click up here in the magic secret corner to get the display. Now I could hook up the oscilloscope, but I don't feel like it. So I'm just going to plug that in and then use my brand new trimmer capacitor here and just start slowly turning this. But on a plus note, we got RGB. The Amiga is working. It's just I don't have an amber. Ambers have been like the bane lately. I have not cleaned this area. This is the audio circuit with the LF347 op amp and the right and left audio jacks. Also the amber enabled disable. See that crustiness? This, yeah. Especially this capacitor. It looks like somebody, you know, wonderful. Doesn't that look great? Look at that. That is what I get. That's what I get. That's to me. Now this looks 110% better. But, you know, when you have the whole freaking digestive system just disintegrate this entire area, it sucks. And that looks a lot better. You can still see some stuff on the Vidiot itself. Now when I got this board, everything's been touched on. Everything has been like touched, like resolder, reflow, trying to repair this, and that's fine, but amber is green and the pins are fused. So chip wise here with amber, you can see all the pins are intact. They're where they're supposed to be. The corners are good, but they have been sanded on a little bit, and the edges, mainly here, the socket's cracked on both corners. There's a crack here too. So I'm going to get on eBay and with money that I don't have and order an amber socket. The benefit is you don't need amber to use this. It will just RGB out of this Vidiot and Bob's your uncle. Denise, Vidiot, you're out. These two guys, poof. This is just for the 31 and the enable disable. Yippee yippee skippy. That is an amber socket. And this is what's left of the guts of the amber. Yes, that white stuff is battery acid. And I destroyed the socket and got all the solder out with my micro Kotto solder sucker with the silicone tip, so you can put it right over the hole and boo. You know, it's got like one here, one there, and one down here, solder blob that were ground pins that were a little bit more tough, and I haven't braided it out yet. But I'm going to use this opportunity while the amber is out and resting peacefully. I'm going to go through the Sprint layout viewer here, yep, on the amber, and start tracing the pins where I can better see the holes with a non-socketed chip. And the idea with that is it's going to make it easier on me to see what I'm doing without having to, is that pin one, is that pin, you know, and then if it's screwed up I can't fix it, so it's easier right now. So I'm going to go through amber while I'm waiting on the sockets. They should be in a couple days, about a week, and I got the sockets for amber in. I'm going to zap one in and then we're going to test it. This is on Oh No Mr. Bill, so she goes right in there like that, and that's what it's going to look like when it's done right there. And then we'll fire it up for another test and see what happens. Okay, so that was about 10 or 15 minutes. Here's our solder job. I contact cleaned it. That's why there's a little bit of residue around the outside. There's her new amber socket. There you go. Amber's back in her new house. Alright, here we go. Amber's in, board set up, external floppy drive because I don't have a DF0. Can't super kickstart it. I got Amiga test kit 1.8 in the floppy. Energizing. What we're going to do is let it boot to the super kickstart screen. This is on RGB, and then we're going to click the top left corner to get the 1.4 beta up here. Click. It'll reboot into a purple screen, and then I'll be able to boot off of DF2. There we go. Put in Amiga test kit 1.8. Get it to the RGB screen. Video, RGB gradient. Here we go. And is Amber dead or is Amber alive? I have a feeling Amber is dead as a doornail. Dead as a doornail. Flipping the switch to non-RGB or non-RTG, non-scan doubled. Non-scan doubled does nothing. That would be the same as the RGB signal through Amber, not scan doubled. You would see something on here. My DeVoom would turn on and the monitor would beep like this. RGB, See how the boom comes on, the screen comes right up. That's what should happen on the amber side of things, but I think amber is toast. I've replaced all the chips, did all the logic, redid the pinouts, left the wires that were correct for the user, rebodged underneath. Everything else functions perfectly. Phase lock loop is warm, as is the new chip I put in. Everything is there, but it's not. I've adjusted on the variable trimmer capacitor to try and bring it in phase. I'm without a spare amber to test. I have no way of verifying that, and I'm not about to take my 3000 apart. So that is going to wrap up Oh No Mr. Bill. We have a functioning Amiga 3000 again. That's great. And she's been cleaned, and I'll give her a final spray down to get all the goop off. Package this sucker up and get it back, because I've had it for almost 2 months waiting for these suckers, PLCC 68s of AMP, and to get them back in. That way there weren't China ones, they're AMP connectors. Really good sturdy connectors with great solder points, good metal, not thin. Amber's not even getting warm, so it's either an issue directly with the chip, the buffer chips are warm, the Oki Data RAMs could be dead, but I would get something out of here color-wise. Red, some kind of phase lock, nothing. Nothing is working, so the only logical point is usually the simplest solution, and that is a dead amber chip. So that is unfortunately all I can do for this one. But at least we have a functioning Amiga. It works again. Everything is tested out. All of the RAM test out. The CIAs check out. Everything is now functioning perfect, minus the amber flicker fixer. But you can put a scan doubler card in there if you really need the 15, or you can do the RGB to HDMI with this one because it is socketed, and do some kind of HDMI out if that's what you really needed to get on a modern television. The most important part is another Amiga saved. Thank you for watching this series, everybody. Consider supporting and subscribing. It really helps me out in being able to do these free pairs. And why I would like to just address one thing. I've received numerous complaints about that I'm stealing business away from Retro Rewind or other recappers, Paul, and even Amiga of Rochester. I'm taking their business. Actually, I'm not. These Amigas that I repair are economically impossible. If you're paying someone $30, $40, $20, $50 an hour, and I have 50 hours into your board, that would cost more than getting a Amiga from John Hertel. So that is just what I would like to say according to the free pairs. I would like to thank all my Patreons once again for supporting me, allowing me to save these Amigas and bring a smile back to the owner's face. So thank you guys for watching. I hope this helps you somewhere, and as always, I hope you learned something.